Hello, everybody. Thank you very much for joining this digital presentation. My name is Francisco Chavez. I work as a project manager in the Engineers Without Borders Norway. And today we are going to hear a very interesting presentation from two very skillful engineers that work in a plastic recycling project in Senegal for our partner, Nia Franks Venner. There is three people that actually contributed to this project. Project manager Katrine Garnes, and the engineers were Marie Bø and Frederick Petersen. But I will not talk much more other than the session is going to be recorded. So by staying unconnected, you accept that the recording will take place. Sorry, and one more thing. The next presentation, it's another very interesting project, distillation system for producing wood vinegar in Tanzania. And it will be in 3 weeks time, 30th of November, 3 o'clock as well. So without further talking from my side, I leave the forum to Maria and Frederick. Please go ahead, guys.
Thank you. So share screen. Okay, so this is a picture of the factory plant in Senegal. So we have the solar panels and we have some buildings and some people working there. So this is the project that Frederick and me and Katrine have been working on. So Frederick is on energy supply. I'm on machines, mechanical engineer. Katrine is a project manager, so she's been trying to hold control us. And then Hilde is the client, or Nia Franks Venner, Friends of Nia Frank, that's an organization that's been around in the area in Senegal since 2009, and they've already done a lot for the community down there. But they realized they have started some production already of plastic products, but they realized they needed some more help from engineers to actually make it improve the production and improve the facilities. So that's when Engineers Without Borders came in. So the assignment was plastic recycling. It was pretty technical, but still we kind of had to understand the problem. We had to understand how the area is, how everything's connected. At least I'm not familiar with Africa at all. So we talked a lot in the beginning and had so much information that we had to kind of gather to do this properly and do it in a good way. So on the energy side, we need to figure out if we're going to connect to the grid or have solar panels, or how we're going to do it, or if we're actually going to have power as well, or just use gas. And for the machines, we need to figure out what machines were required to make the products that we wanted to make. And we also had to budget so that we know, like, the ideal goal is that this factory and this whole project runs by itself after a certain amount of time, so that it doesn't continuously need subsidizing from Norway. So the project has been in 2 phases. So the delivery for the first phase has been kind of just like the background check and figuring out how to do everything and then make a project plan. And then the second phase is actually ordering the equipment and getting it up and running. So this presentation, actually, we cover everything, both phases, actually. And then we have an ideal plan, and then we had to, like Hilde had already, Nia Franks Venner had already started trying to get funding for this project. So Frederick and I ended up helping writing the application for funding from Handelens Miljøfond, or Norwegian Retailers Environment Fund. And then we had to make some adjustments to the original plan to get the funding we wanted and needed. And then we had to order, and then we had to commission everything. So it has taken quite a lot of time since we started. We were first hired in August 2021. And then we started with working with the application and just gathering all the information we needed to get started. And then the funding was actually approved in January 2022. And then there was some master students and Katrine who actually went to Senegal in March. And then we started ordering the equipment in October. But stuff weren't, like, everything doesn't go as according to plans. So the delivery took, like, the machines, most of it was delivered in November, December, and mounted when Fredrik and Katrine were in Senegal again. I wasn't able to go, unfortunately, myself. So Katrine had to, I just put all the responsibility for the machines onto Katrine, and she handled it pretty well. So Fredrik was working on this, mounting the solar panels and all that stuff, and then the machines were built in March, and then the last piece of the solar plant was delivered in March as well. And I think Fredrik will mention why it took so long. And then everything was tested in May. And then now we're working on just wrapping everything up. So I guess a lot of us Norwegians, I had to actually look at the map at least to figure out where Senegal is. And it's on the as far west in Africa as you can get. And it kind of wraps around Gambia. And then the site where this factory is and where Oppdragsrapport has been for a long time is just south of Gambia. So the closest international airport is Banjul in Gambia. So I'm pretty sure that's where people usually fly to get there. And then this is the close-up of the area. So this red circle is where kind of the area that's covered by the project. So you have 5 smaller villages within this area that the project actually collects waste from, in addition to covering the shoreline, which is 18 kilometers long, and also the river network. So a lot of wetlands and mangrove forests around the rivers here. And just to mention, there's the closest biggest city is Sigensjord, which is an hour-and-a-half drive from the factory site. And that's where, if we need equipment and need to get stuff done, that's usually where you have to go. So the area, it's covered in plastic pretty much everywhere. It really is a lot of plastic because there are no waste disposal systems anywhere. So the waste is burned, or it's put in big piles, or it's just left on the ground where you happen to drop it. So the animals, like this traditional worst images, you see that animals get trapped in plastic and old fishing nets and all kinds of things, and animals eat the plastic. They don't know the difference between plastic and food. And there's marine protection area in the ocean just outside the project area, and it's there's definitely a need to clean up and make use of the waste. So how should we get started? So we kind of started looking at, and that also had been done a little bit before, looking at the types of plastic you can find. So there's a lot of food containers, hygiene product containers, shampoo bottles, soap. And there's also these water sachets, or just bag made of plastic foil, that I never saw before I actually started on this project. Those are there are a lot of those. And there's buckets, like thicker plastic buckets, cans, motor oil, and also electronics waste. And that's usually very like mixed. So it's not only the plastic, it's difficult to separate the plastic from everything else. So when we kind of had an idea of what kind of plastic there is, then we started looking at what products should we make, because we wanted to make something that's useful, that people can actually use, and that could replace something that's difficult or expensive to find. So, and it has to be easy to make as well. So building materials then, so this table is in the phase 1 report that's going to be published soon. So we kind of listed up a bunch of different products that could be made from plastic, and also plastic and sand mixes. And then trying to look at what kind of material they could replace. For example, concrete is not very, it's difficult to, it's expensive and it's not very environmentally friendly. So it's good to replace concrete. And it's also wood in the area. There's a lot of like bushes and stuff. There's not forests like that, so you don't really have lumber. So we figured out that to extrude like profiles, like the colorful picture down there is would be a good product to make. And those hexagon tiles or bricks on the left side, those are actually they were already made at a smaller scale at the project before we started actually. So we wanted to also improve that production process. So then we kind of the factory. So that kind of mainly consists of the energy system, energy sourcing, like everything we needed to get power. And also then the second part is the machines and the production equipment. So then Fredrik will first go over the energy sourcing topics. So are you ready, Fredrik?
Yeah, thanks. Just to start off, before going into the nitty-gritty detail of the solar installation, I just wanted to take a step back and sort of look at the broader picture of energy access in Africa, and hopefully provide some motivation for why just installing capacity in Africa is a good thing in of itself. So if you can go on the next slide, please, Maria. I had a look at the International Energy Agency, and they publish some numbers on the access to electricity in Africa. And as of 2022, there are 600 million people without access to electricity in Africa. Most of these reside in sub-Saharan Africa. And as you can see on the picture on the right, the darker blue the color is, the less people have access to electricity. So in the central parts of Africa, so in Ethiopia, where there's been a civil war, the access to electricity is super low. So there's a long way to go for the world to reach our goals of achieving modern access to modern electricity for everyone around the globe. In Senegal, it's about 70% of the people that has access to electricity, so 30% does not, and that represents almost the size of the population of Norway at 5 million people. That's point number one. Point number two is to follow up on that. I compiled this. Could you please change the slide, Maria? I compiled a slide showing the electricity usage per person and comparing Norway to Senegal, just to provide some context. And it turns out that Norway actually consumes 87 times more electricity per person compared to Senegal. There's quite a high difference here. And the point I want to get across is that every new capacity added in Senegal is good in and of itself, regardless of the use case. Obviously, our project here is super good, but just the adding on a new energy capacity is a good thing itself. So with that in mind, if you can move on to the next slide, Maria. We move on to the actual project. As you mentioned, Maria, we started off a little over 2 years ago, and the first thing we did was to do a feasibility study for the project. And on the energy side of that, we assessed 2 options for sourcing electricity. Option number 1 is to connect to the existing grid infrastructure. Option number 2 is to build an off-grid system with solar battery. So we assessed these 2 options on 3 different criteria, on sustainability, on stability, and on cost. And on pretty much all the criteria, the off-grid system comes out on top. It's 100% renewable. The transmission grid in Senegal, on the other hand, is largely fed by fossil fuels. Most of that is diesel generators. The transmission grid is quite weak. It's frequent outages, high losses, unreliable, and so on. Well, the off-grid system, it's stable, it's predictable solar conditions, so it generates when you want it to generate. And you also have a battery that provides the stability you need. On the cost side of things, it's a little bit more even. The investment cost, so the upfront cost for the off-grid system is slightly higher. It's at 220K-ish compared to 180K for the grid connection. But you can enjoy free renewable electricity throughout its lifetime on the off-grid system. Whereas if you connect to the grid, you have to pay for the grid tariff, for the retail tariff, which is a operating cost. So over time, it will be more expensive with a grid connection also. Next slide, thanks. So the off-grid system we installed is a simple system here represented in a one-line diagram. So we have the solar array to the left. It's a 10 kilowatt peak solar array feeding into the charge controller, MPPT charge controller, which charges the 20 kilowatt hour battery, and this charges it accordingly. Then we have the inverter. It's a 10 kilowatt inverter converting the direct current to alternating currents, and the AC output is at 400 volts at 50 hertz in 3 phases. So we decided to go with a 50 hertz inverter here. The system frequency on the grid in Senegal is also 50 hertz. So that means that every sort of electrical appliances in Senegal will be able to connect to the AC side of this system. And also we then have to make sure that the machines you procure, they are compatible with this configuration. And that was quite a bit of a hassle actually to find a machine that was compatible. Next slide, please. The components in the solar system is listed here. The solar panels, the inverter, the battery, the mounting frame, the charge controller, the electrical protection, and the mechanical protection, the cables, and so on. All of these are sourced locally. And by locally, I mean in Senegal or in Gambia, typically in the capitals, so in Dakar and in Senegal and Banjul in Gambia. The exception is the inverter. We did the procurement research in sort of mid-2022, and this was in the middle of the energy crisis that we have seen. Prices were through the roof. The supply chains was severely hit. So obviously that affected Senegal also. They ran out of stock and we just couldn't find an inverter locally. So we had to procure it elsewhere. So we went to a supplier in China and had it shipped all the way to Banjul, where we picked it up and drove it down to Senegal. Next slide, please. Over to the installation. The mounting system is made locally in Kaffontein, which is the municipality where we are. It's made by a local welder who welded the system based on drawings and measurements. And we anchored the mounting system into the ground using concrete. So you can see on the left here, we're digging the holes. And in the middle, we're mixing the cement and the sand and the gravel and water to make the concrete. We had to do this by hand, and obviously the water pump wasn't working at the time, so you have to like go and collect the water. So it's a bit of a work to just get all this mixed. But we had a lot of hands and a lot of motivation, so we managed to do that. And then we anchored the frame into the ground using the concrete, and that typically dries within a couple of days. It depends a little bit on the consistency that you have, how much you use, the temperature, and so on. I think we waited about 4 or 5 days, and it was more than dry then. So probably you could get away with waiting 2-3 days for that. Next slide, please. Installing the panels, it's a plug-and-play type system, nothing special. One design choice we made was to use these small metal pieces you can see on the right to sort of clamp down the panels on the frame. And what we did was we welded these pieces onto the frame. And the reason for that design choice is to mitigate the risk of theft, which is quite prevalent in the area. These components are high value and they're attractive to thieves. So we decided to do it this way. The downside to that is that it's quite of a hassle to change out the panels if you need to, if a panel is faulty or it breaks or whatever it might be. It's a bit of a hassle to change it out, but it's a sort of a give and take design choice we made. It's worked well so far, and hopefully it will keep working well in the future. Next slide. The cable trenches are dug all the way from the solar panels to the technical room. So you can see the solar panels on the left and the technical room in the middle. It's about 15-20 meters of trenches. The cables are covered in these water pipes, so PVC pipes, which might be a little bit of overkill, but at least they're very well covered, and it sort of protects against all small animals that can bite on it and the outside conditions in general. Next slide, please. The installation of the all the power electronics was done in a technical room on the house you saw in the middle on the last slide. Everything is mounted on the wall. You can see the inverter on the top, middle, the charge controllers on each side of the inverter, the batteries on the bottom, and the DC breakers in between. And sort of a point here is that the power electronics should be installed inside in a shaded area and make sure that there's good ventilation, good airflow, so that you increase the lifetime of these components. Next slide. So to round off, there's some key takeaways for doing a solar installation here. In general, it's the same. Doing these types of installations is the same principles regardless of where you are. But there are some location-specific aspects to consider when doing this type of installation in a remote part of West Africa. Some of the points we touched upon: the risk of theft. These components are high value, so preventative measures for theft should be considered and implemented accordingly. Point number 2, the climate and temperature. The climate is quite harsh. It's warm. It's a lot of sand everywhere. So the power electronics should be installed inside in a technical room. Make sure there's good airflow. And also we found that rinsing the panels from sand, so washing the sand away from the panels, improved the efficiency of the generation quite a bit, up to 20% actually in some cases. So having a good routine on rinsing the panel is good. And then the last point, there's a general lack of standardization. There's a lack of safety guidelines and building codes. These systems will rarely, or in practice never, be inspected retroactively by any sorts of electrical safety authorities or the likes. So it's super important to do a proper risk assessment yourself. It's up to you, and do it prior to, during, and after the installation. That was it I have.
Okay, so then we will move on to the machines and the production equipment. So already when we were brought onto the project, the Nia Franks Venner and Hilde, and together with a great team down in Senegal, they had already done a lot. So they had acquired a property, and they had already built these two buildings that you see top right. The left one is just where the janitor lives, so there's always someone living on the property to watch over everything. And then on the right side, there's the production building. So they're big open spaces where you actually make the paving bricks that we will talk a lot more about. And in the back of the building, there's two rooms that is used for the machines and also for like storage of the plastic so that keep it dry and stuff. And also there was a well with the solar pump that didn't work when Fredrik needed it, apparently, and like a big wash basin where they can wash the plastic and clean the plastic. And then the middle picture shows the big melting pot used for melting plastic and mixing it with sand. And when we started, then this thing was wood fired. So it produced a lot of smoke, both from the actual wood burning, but also from the plastic burning, because it was pretty much impossible to control the temperature of the plastic. So even the neighbors, like the workers, of course, were affected by the smoke and gas, toxic gas, and also the neighbors. And then on the right side, there's a lot of different molds to make the paving brick. So the most common ones are hexagonal ones. And then during the project, we started looking for machines, and we had kind of an idea that we could go on there's this precious plastic concept that's open source. So you can go online and you can actually download 3D CAD data for making like a shredder that makes that cuts plastic pieces into tiny granule, and you can make molders, and you can there's a lot of stuff. But then we just started looking at it and really realized that this is going to be really time consuming to follow up. Well, first of all, actually make something that works, because you had to modify it a lot to make it safe and adapt it to the actual use, because the models that you can download, those are really basic, so it always needs some upgrades. So then we can go on the Precious Plastic Bazaar, which is a kind of a website there where producers use the precious plastic and have done those upgrades. We ended up actually buying the shredder, which is the one on the right, from a company, Studio MBB in Netherlands. This one, at first we thought we needed a bigger machine, but then this one is actually powerful enough and it has high enough capacity for what we need it for. And it also has done a lot of those upgrades with regards to safety, so that you cannot put your hand into the knives, and the rotating parts of the shredder are covered, and there's emergency stop buttons, and so it's safe to use. And we ended up, instead of that, that was one of the modifications we had to use that I mentioned for the application. To get the funding, we had to modify. So we weren't able to buy the bigger extruder that we wanted, like an extrusion machine to make those planks and lumber. So we had to modify, and we ended up buying a smaller molder. The one in the center is a manual injection molder. So it's there's a video afterwards, so it explains how it's used. And then also there's the laundry machine that's used for washing bigger like pieces of plastic before using the injection molder, because it requires really clean plastic. And then we also tested a few different gas burners to replace the wood because we haven't been able to electrify the actual melting process. So we had to take a middle step and use gas instead of the wood to heat up and melt the plastic. So that was kind of, we wanted to make it electrical, but it just didn't work out that way. And it was cheaper and a lower investment to buy the gas burners. And then, yeah. So the products that are produced today are the paving bricks that are showed on the bottom. So they are, how big are 17 centimeters across, and they weigh approximately 2.5 kilograms each. And they can be used for like private courtyards, outside, I don't know, wherever there's a flat surface and you want to cover up so you don't get sand. And there's both like public places that have bought them already, and also private houses. And then on the top right, there's like smaller decorative tiles. Those are about 10 centimeters across and around 5 millimeters thick, something like that. And they can be used to just cover up tabletops, cover up like backsplash behind your kitchen sink, stuff like that. And those are considered more like those with the manual injection molder, you can't make stuff that's any much bigger than this because the pressure you need to push down with is really high. But it's a start, and it's a good way of actually educating the people down there so that you see that it's possible to make like pretty nice products from the plastic, and they learn how to just work with the plastic. So the production process, this is kind of a big diagram, but it's common for both those products. And it starts kind of with the cleanups and collecting the waste, and then it's sorted, like roughly sorted. So removing electrical plastic, for example. And then it's cleaned, removing sand and like debris, like big pieces of stuff. And then it dried, and then it's sorted again, like more thoroughly, and cleaned and soaked, just to be able to remove even more debris, and also labels, paper and glue labels. And then after that thorough cleaning, then it should, actually today they don't, for the paving bricks, they actually don't shred the plastic, but they really should shred the plastic. So this diagram kind of, it shows the way it should be done. So then you shred the plastic in like slightly bigger pieces, 6 millimeters, and then you preheat the melting pot first so that it's hot before you put the plastic in. And then you heat up and mix with sand and pour it or put into molds, and you let it cool down. And then for the injection molder, it has to be smaller pieces. The shredded plastic has to be small because then it melts better. So you first shred it into small pieces, and then because you need to use plastic with the same melting temperature, and that's quite sensitive on the injection molding machine. So you need to remove PET plastic from the mix. And that can be done as like float sorting. There's a picture of it afterwards. And then then it gets wet, of course, because you use water. So it has to dry again. And then it's really important that the granules are dry before you put it into the molder. And I have videos of both these processes that we can see afterwards.
Maria, just
a
remark, it's about 10 minutes left, so to give room for questions and answers at the end, just keep in mind.
I think that's good. And then these red arrows shows where the power comes in, where we need energy. So we have electricity for the shredding, and also we can use electricity for the preheating of the melting pot because we have this large electric heater plate that we can use for that. And then the heating here is with gas. And then this side, there's electricity in both. So then the sorting. So first, everything is collected from around the area, and then it's rough sorted into these boxes with netting into different types of plastic. So you kind of use like the product type to do the rough sorting. So, for example, like PET, those are usually bottles of water, juice, shampoo bottles, egg boxes, stuff like that. And then you have HDPE, polyethylene, and LDPE, low density and high density polyethylene. Those are like milk jugs, juice containers, trash bags, grocery bags. So you kind of sort on the product type to find out, or to just do the rough sorting, because it's usually made out of that and that plastic. And then the bottom picture shows that float sorting. So then you have to shred the plastic first and then put it into a case of water. And then since the PET is high density, it sinks, and then the PE floats. So then you can remove the PE from the mix. And the PE and PP, I think, would float. And then those have pretty much the same melting temperature, and they can be mixed and used in the injection molder. And then there's the just illustration of the cleaning steps. So it's first roughly cleaned and then cut into smaller pieces, and then more thoroughly cleaned and soaked to remove the labels. And then for the decorative tile production, the injection molder, then the pieces are laundered, like using the washing machine in addition to make it super clean before it's shredded. And then there's a video of the paving brick production. So it doesn't have any sound, so I'll see. So it kind of shows the property with the buildings. And this is the melting pot, which is insulated with these rock wool mats. And here's kind of a sample how they can sort. So they have this example products that they know which plastic is. And there's the melting plastic. So the plastic is melted first, and then they add the sand and mix everything into this dough-like mixture, which is pushed into the molds to compress it really thoroughly so that it actually goes out into all the corners. And then it's left to dry once they're finished and happy. And then this is the final product, and this is how it looks when it's put on the ground. And this video I clipped it out of a video that Handelens Miljöfond made when they visited the site. And then I have a video of the shredder process. So these are like the typical size of pieces that you can put into the shredder. And like some pieces you have to compress, then it eats it better. And there's a push stick in the back that can help trying to push the plastic into the knives. And this was a kind of a big piece, so you got a little bit stuck, and then you can actually adjust the speed and you can adjust the direction. So you can run it backwards so that the big stuck plastic pieces can actually be easily removed. So that's a way of, here you see the knives and stuck plastic, so you can actually run the machine back and forth to make the plastic loosen. And there was also a little trial taking like extruded just pieces from the injection machine to try and shred them again. And that was a little bit more difficult. But here you see really well how the knives look and how they rotate and kind of eat the plastic. And this is the granule made from the already melted plastic, so it's kind of dusty, like the normal shredding just from plastic. It doesn't have those fine dusty particles, it just had the big particles, but I couldn't find a video of it. And then it's the injection molder. So you put the shredded plastic into this chute, and you just use that stick to compress it a little bit. And then it's just a simple lever pushing down into it stops into the mold until it stops, and then you have to unscrew it. And you have to loosen all those 4 screws. And I've clipped this video a lot, so it takes quite some time to actually open the mold. And this is not the best tile that was made. It was one of the first tries, but these are the tiles that after a few tries we're able to make pretty nice, even tiles. And one part of the project was also kind of look at the health and safety and the environment. So for the shredder side of it, the left or the right picture with all those text boxes, that's a poster that we printed, and that's actually in the workshop. And there it's noted down all those extra security measures that's been taken to make the shredder safer, to reduce the cut and the crush hazards. So that big chute, the aluminum part on the right side of the shredder, that does that you can't get your hands and your fingers into the knives, down to the knives. And then you have the emergency stop button, and you have all these labels that you can kind of argue are being followed or not, but at least they're there, so it's covered. And then there's noise also for the shredder, so it's recommended to wear hearing protection while shredding. For the tile production, both the injection molder but especially the paving tile production, then when you melt the plastic, there's always toxic gases. So one of the first things that was done was to buy proper filter masks with replaceable filters. So the workers down there always use masks when they handle and are around the steaming hot plastic. And also there's also, of course, hot surfaces. So we have a bunch of like these thick gloves to handle everything that's hot. And now we're nearing the end, actually. So the project is actually, there's a Facebook page for the project, the Caravan Plastic. That's the name of the factory. So this Facebook site is actually maintained pretty often. It's only a day or two since they put pictures on there. So they, there's a lot of pictures and a lot of information on the progress at the factory. And then there's the Waste at Work project, which is this kind of the overall project, including the plastic collection and cleaning part of the project, and also education in schools and all the everything that's been done in the area in addition to the actual factory. It's also explained on this website. And then soon our reports, Fredrik and my report, will be available on UG.no. So that was everything we had. So then we asked Hilde if she could say a little bit actually about what's the plan forward. Are you ready, Hilde?
Well, maybe we could say, as a clarification, Hilde is with Nia Frank Benner, Friends of Nia Frank, which is our partner, local partner down there. through which this project was executed. So will be nice to see if she can unmute herself and share a little bit of her thoughts and comments regarding the cooperation with us, with these 3 engineers and EUG at large, EWB. You seem to be muted, Hilda, in case you can hear us.
Maria, if you have the next slide, I can maybe try to see if Hilda is coming. I don't know. I tried to contact her, but she...
Yeah, I can actually do that as well. I kind of read through it earlier.
You can, then she can jump in if she...
Able to connect. Yeah, that's a good idea.
So the points that Hilda wrote down earlier today was actually quite the technical part of the future work, and there's a big aim to actually make everything electrical, to get rid of the gas, because you have to buy the gas all the time, and it's in the long run it's expensive. If we can use the solar energy that's already there, and actually we have found out that even running all the electric machines and equipment at once, it still gives enough power. So it's actually, we have plenty of power, so there's room for more equipment actually. So that trying to make that melting pot electrical as well is a big goal. And then also to control the temperature in the melting pot, so that we avoid setting fire to plastic, because it's still, even though switched to gas, it's easier to control the temperature, but it's still not well enough controlled. Because once the plastic burns, I saw Hilda, but I can just continue. Yeah. I think I was just going. So we want to try and not set fire to the plastic actually, because it loses some of the properties once it has burned. It's not a lot of burn, and we still see that the tiles or the bricks, they are still pretty solid and in good quality. So it works well the way it is right now, but it could be a lot better. And then the production must be more efficient to reduce the cost. So right now, it's a little bit difficult to sell the bricks at the price that actually makes a profit. So it has to make the production more efficient, or and figure out what price people actually can pay, and that would still cover the costs. And then at last, more knowledge about plastic, what plastic types can be used for what. And then maybe Hilda is there, so she can tell a little bit more about her experience working with Engineers Without Borders.
Yeah, I was thrown out for some reason. I don't know why, but here I am again. First, I'm impressed about this report. Really, it shows me how much has really been done down there. When you sit inside the project, you don't see everything. But thank you. Very, very correct report, I think, presentation. And when you see the more this project develops, the more tasks are coming up. We see that we have a lot to do. The more we do, the more tasks are necessary to look into. So, but we have from the start with the Engineers Without Borders, we have done great steps, many big, great steps. And if it hadn't been for EUG, we had stopped this project. This project would have had to stop. So, but it's so many things that are popping up all the time. But like Maria and Fredrik said in the first report, that they have pointed out so many possibilities and we have discussed so many things that we just have to try to keep a kind of a way through all this, decide what to do and what we have to wait to do. There are many things we'd like to do to improve all the processes, to find maybe we should have different products, maybe we should do this or that. And one thing that I would like to really look into later is that to stop using sand and use broken glass instead, if that would be possible at any point. But on the last slide, that was actually what I think we should, that Katrin Maria just read. I think it's electrification, is it, of the melting process, and bringing all process over to the to solar. That is the most important, and we have a lot of power, so that is a luxury problem that we cannot use it for all its worth. So actually, I'm not sure what more to say about, but if it hadn't been for IUG, we would this would not be possible, because we understood from the first moment that actually from the point we started, that we couldn't go on with the using wood, and because of deforestation and poisonous gases. So yeah, thank you.
Thank you very much, Hilda. It is very nice to hear, and encouraging to hear that this actually has been for the benefit of the people down there with your cooperation, and we thank you for giving us the opportunity to help you, and thus helping us to meet our mission in IUG. We have few minutes. If there are questions to anyone, please feel free now. One at a time, not all together, please. Yeah, you seem to be thinking. Heidi, okay, this time you first, next time me first. Go ahead.
No, first of all, just a fantastic presentation. I mean, it made sense, and I feel that I understood so much more about engineering. That's a comment first, but thank you, thank you. I was just, I think you were mentioning it both, but it's like you need a lot of hands to do both what you did with installation of the solar panels, and it also seemed quite a lot of manual processes in the production of the tiles, etc. Who are the people you cooperate with? How many? Where do they come from? Who are they? I don't know if it's to Hilde or to Katrine and Fredrik, who have been there. Yeah, thank you.
Maybe Hilde or Katrine could answer that.
Yeah,
Hilde can maybe add. I just want to say one thing. They come from everywhere. That was the feeling when I came there. It was people everywhere. That's maybe a little bit, but of course it's not so difficult. How can I say, to find people who need work? The difficult thing is to organize and to find the right people. So what we started was a lot of people coming, and then we needed to organize, and then we need the right people. So you have to educate them and find the right people to work. So it's kind of a luxury problem, and then it's kind of another problem is to find the right. But maybe Hilde can say. And some of the people we already had, a lot of them, before I came into the project. And for now, the people we have is the people we started with mostly. Yes, Hilda.
Yeah, we have some good people, and we have some are really devoted, and that we trust more, just a lot, maybe not 150%, but we trust them. And then there are a few people, there are many people roaming around looking for work, so they are not devoted to this project, and they are sometimes not turning up, and yeah, they just need work, and we don't pay very good salaries, so it's not very surprising that they just if they have something more important to do, you can experience that they don't turn up. So but we are also working with, we have found a technical school that we have started to cooperate with, and they have made helped us a lot. They have made us a better some equipment that we can use to shred smaller pieces. I think Marianne mentioned it, and we really trust. We want to develop that cooperation, and maybe we could after some time try to ask if some of them would like to work with us. Maybe before, at least before they have their own proper work and good salary, they could maybe come and have some interest of working with us. And we have, if you look at our website, we have a story about one man who has started his own recycling place, and that is so interesting. And we hope to help him, and he can help us.
Thank you, thank you. Mariana, you have your hand up.
Yes, thank you. Really interesting to listen to you, Maria and Fredrik. Thanks a lot for a very good presentation and very, very good work. And that includes you also, Katrine, though you didn't speak now. I was wondering about the solar panels. So they have the capacity to power or to electrify the melting pot. Is it expected that there will be any excess capacity after that as well?
I think there can be some excess capacity. It depends on when you use the electricity. So if you can sort of avoid using everything at the same time, then you can sort of do a lot of processes in parallel, as long as you can sort of time it accordingly. But as it is now, it's a little bit oversized for the machines we have there right now. So this capacity to do electrification of the melting pot that we have now, for sure.
And also on the shredder, we have had all kinds of issues with the precious plastic shredder in other places. But is it working? Has it been working well since it was installed? Have you, or are there any big challenges with it? It would be just interesting to hear.
Katrina has been the one testing it, so I'll leave that to her.
Now how can I say, as Maria said, we bought it, how can I say, as one piece, and it was delivered in one piece. Very carefully it came down. Final, I was just laughing when it came to the last way, because then it was inside this small car just bumping in the head, but everything was fine. And it has been working from, how can I say, day one. No problems. So yeah, and so that was how can I say, a good thing. The next part now is when it needs how can I say, service or some maintenance, how that will work. But that's why we also are very interested to have this cooperation with the technical school, because they have been there, they have looked at it, and they have equipment to help us if we need to, how can I say, make some spare parts or something. We also bought spare parts together with shredder, so if something happens now, we have it at this site.
That's good risk mitigation.
Thank you very much. Okay, time is up, but I have one question to Maria and Fredrik. If we were to repeat to a new project, based on the equipment that was selected and the considerations, including deliverance, installation, and everything, would you have repeated the same equipment, or will you try to find a replacement? General question, don't need to go into many details.
Like for
both the machines and the electrical and the solar and electrical system.
So first, Maria, for the solar system, I think we would do it the same way, given the sort of conditions that we were in at the time. We were obviously in the middle of an energy crisis caused by the Russian invasion of Ukraine, so there was high prices, long delivery times, but I think we managed it quite well, actually. So wouldn't really have changed too much on that. It's a differential to around the system. It's
Maria,
and good.
Yeah, for the shredder at least, I'm really happy with how it took a while to actually find the right manufacturer, and actually because we had to make a few changes and make sure that everything was understood and all that stuff. But that is a lot easier when there's someone from Europe, unfortunately. And it was kind of a project trying to find out how to ship everything to Senegal as well. But it works, and because it was put together and assembled in Netherlands, We didn't have to. We couldn't do any mistakes putting it together,
Right.
so we just had to
All
turn
right.
it on pretty much. Yeah.
Thank you. Thank you very much. That's good to know because there is more and more projects coming. Well, we are 2 minutes over. We started 2 minutes over also, so we are consistent on that. Thank you very much for a very, very good presentation. It has bring light to many of us about the project and understanding again a bit deeper this issue of the recycling of plastic. Has been a fantastic experience. Thank you very much to the two of you, Maria and Frederick. Thank you to Hilda. Thank you to Katrina. And yeah, soon will be this report also. It will be together with with a link to the presentation. Will be set up a link for the report it is, so whoever wants to read it, it's accessible there. Well, remember next 30th of September, November, end of this month, the last Thursday in this month, there is another very good presentation. As I said at the beginning, the distillation system for producing wood vinegar in Tanzania. I hope to see you there. And once again, thank you very much. Have a nice afternoon. God bless.
Thank you.
Thank you.
Thank you.
Bye-bye.
Bye.